Hey guys, Paweł here, and today I would like to talk about REST APIs. In about 986, Bjarne Nihar-Johnsen, and I'm very sorry for pronouncing in this way, a North Icelandic explorer is believed to be the first to see the coast of North America. But he never landed on the land. 5 centuries later, Christopher Columbus, an Italian explorer, arrived on Hispaniola, an island lying east to Cuba. The island was already occupied by natives. They needed to find the ways to communicate. As with every first meeting among foreign cultures, communication evolved at first through sign language. Eventually, each side would communicate to each other essential words necessary for survival. The Spanish and English languages today both incorporate words derived from the Tainos, the native of Hispaniola, and learned by Columbus's crew. For example, the word hurricane derived from the word huracan, and the word barbecue derived from the word barbacoa. This initial expedition established new ways of communication between the natives and the Spanish travelers. Exactly, the communication protocol. Now let's move this on the ground of computers communicating with each other over the internet. If every application would speak only one language that is understandable to this application only, then we wouldn't have communication and we wouldn't have the web. World Wide Web. Originally, it was designed by scientists in CERN, Switzerland. Back then, the goal of the network was to easily exchange scientific information. On April 30th, 1993, the World Wide Web went public. But to load a web page, the browser, a thing you use every day, needs to understand what the other side, the server, is saying. But before that, it needs to know how to communicate with the other machine that hosts the web page. The scientists figure out a protocol used to transport a message from one computer to another. In 1991, just 2 years before the official launch of the web, Tim Berners-Lee and his team published the first specification of the protocol. They called it Hypertext Transfer Protocol, or HTTP. It described how two peers communicate over the internet. We won't be getting into very specifics of the communication on the protocol level. We will stay on the application level. It is a level where applications can open a connection to another machine using the underlying transfer protocol and exchange the data. So, what makes, say, the Instagram application on your phone to be able to communicate with its servers and get the list of recent pictures of your friends? We call it the Application Programming Interface, or API for short. It is an agreement between two machines of how to talk to each other, a contract if you will. So let's take a look of how such communication can look like. Again, we are skipping parts related to protocol negotiations or making a connection. Applications almost never manage this part. Operating system or frameworks does. To initialize the communication, the client, our Instagram application, needs to send a message to the server asking for a thing. This thing may be anything: a website, a list of images, a list of latest posts, or anything else that can be transferred over the internet, which is literally anything binary. The message is as follows: get a posts resource over an HTTP 1.1 protocol. I am requesting the data from API Instagram.com host. I am accepting English language. Personally, I can also speak Polish, but let's stick to English for now. I understand or accept JSON messages. After sending this message, the other side, the server, understands it to ask it to serve a list of recent posts. The posts should be, if possible, translated to English language. Because the requesting side, the client, can only process the JSON data, the returning message should be formatted according to JSON rules. The response is as follows: I understand the 1.1 protocol. The response code is 403, which means you are not authorized to request this resource. Current date is today. I have a message that is 120 characters long, and it is formatted as JSON message. And here's the rest of the response. Before we get into the details of what just happened, and why we didn't get our list of posts, let's talk about what is this pair of request and response messages. Just like the first settlers in North America, the client and the server have to establish a common vocabulary to name things and understand each other. The HTTP message is specified by the HTTP protocol and is always the same. In the first line, it always describes the format of the message for both the request and the response. The request message starts with the type of the operation we are requesting, like get a resource. Then the path to the resource, which tells the server what you are asking for. Finally, the last part of the status message is the protocol version you are communicating over. The most popular version of the protocol today is HTTP 1.1. We also have version 2.0, which has a lot of performance improvements, but it is not yet as popular as 1.1. The corresponding part in the response message is the response status. It includes the protocol version again, the status code, and the status message, sometimes called the reason. So the server responded with a status message saying that the response is using 1.1 version of the HTTP protocol. The status code is 403. The reason for this code is that the request did not carry any user identification, also called the credentials. The HTTP protocol defines a closed list of response status codes, and they are split into 5 basic groups. The 100 group is the protocol negotiation group, and because it is almost never carried by the application, we won't be talking about it. The 200 group is the acknowledgement group. It basically means that the request was understood by the server and it was processed or is still being processed. It is also called a success group. The 300 group is the redirection group. When a resource changes the location, one of the status codes from this group is used to inform the client about this fact. It is also used when to finalize the transaction, the client has to visit another URL. The 400 group means that the server couldn't process the request, and this is the client's fault. Like in our case, 403 status means missing credentials to a requested resource. Finally, the 500 group means the server error. It is not the client's fault, but server programmers forgot to handle some specific case. After the status code part, there is the reason part of the status message. This optional information contains a short description of why this specific status code was returned by the server. In our case, the server said not authorized. This is also a standard HTTP message. The HTTP protocol is stateless. It means that one connection is completely independent to another. Even if the application on the first connection introduces a user to the server, after making a new connection, this information is lost. But the protocol is not sessionless. This means that you can start a session on the server then returns a token and tells the browser, if the client application is a browser, to store this token, for example, in a cookie. Later, this cookie is reported back each time a request is made to the server. Instagram application, however, does not handle cookies, nor does it have to. There are a number of authentication protocols that allow to authenticate the user. Then, the application uses some kind of token to make a request on behalf of the user. In case of the Instagram application, it asks the user to log in to the authentication service used in a browser. After the user log in and allow the application to make requests on behalf of this user, the authentication server redirects the request to a special URL configured for this application. The response contains a special token called authentication code. This code is later securely exchanged by the application with the authentication server to the so-called authentication token. This token is used in the request message to identify the user. The final token received by the application expires in some time, usually it's about an hour. The application can, however, request for a new token without user interaction because the user already allowed the application to access the data. What I just described is the OAuth 2 protocol. To use the token to authenticate the user and finally get the data from the server, we have to learn about HTTP headers. The headers is the second but optional part of the HTTP message. It is additional information sent to server so it can properly process the request. There are a number of default headers and response headers. For example, the accept header mentioned earlier means that this client accepts a specific format of the response, like JSON, XML, and so on. There is another standard header called authorization. It is something we can now use to tell the server on behalf of whom we are making the request. Auth by default is using the bearer token type. Now we add the received from the authentication server token value. Such a composed message sent to the server now returns status 200, meaning success. That also means that the response body contains a list of posts we are hoping to get in the first place. To properly decode the message, we should check the content type response header. It should be application JSON, which is something our application can decode. Other types could result with an error if the application does not support it. The response message contains a string that we can parse as JSON, and the application can start processing it to render data in the view. This is how generally an API works. An application composes a message to the server. The server responds with another message that should be interpreted by the client. This kind of communication is called an API. To formalize this communication, we designed languages for describing APIs like RAML or OS. Such languages allow creating a vocabulary the API speaks, the data types, and tells what are the entry points to request the data. We call them endpoints. This API description can be used to generate a developer documentation using tools like API Console, or to automate some processes around the API operations like scaffolding API structure in your server application code, or to generate routing configuration. The takeout from this tutorial is APIs are the way how applications communicate with each other. It describes a formal language of the communication while using the standard HTTP protocol. This communication protocol is a contract. Application has to create a message that the server understands, and the server has to create a response that was formalized in API specification. That's the Web API's basics. Let me know in the comment section if there's something you would like to know more. If you like this video, please subscribe to see more content like this. See you next time, and thanks for watching.